This is Group 1's Pre-Calc project. I'm Allie Herding.
I'm Bryce Fauble.
And I'm Mackenzie Curcio.
Tune in.
The first equation is y equals -3 sine multiplied by x plus pi. The negative at the beginning of the equation causes the graph to reflect over the x-axis. The positive pi being inside of the parentheses causes the graph to move left pi, and the 3 being bigger than 1 causes the graph to vertically expand. To find the amplitude, you take the absolute value of a. A in this equation is -3, so the absolute value of -3 is 3, which makes the amplitude 3. To find the period, you do 2 pi divided by the absolute value of b. B in this equation happens to be 1. So you do 2 pi divided by the absolute value of 1, which leaves you with the period being 2 pi. To find the frequency, you do the inverse of the period, which makes it the absolute value of b divided by 2 pi. In this equation, b is 1, so you do the absolute value of 1 divided by 2 pi, which gives you 1 divided by 2 pi. To find the phase shift, you do -c divided by the absolute value of b. b in this equation is 1, and c in this equation is positive pi. So you do -pi divided by the absolute value of 1, which leaves you with the phase shift equaling -pi. To graph this equation, you start with the original points of y equals sine x. The x-intercept is 0, 0, and the maximum is pi over 2, 1. Another x-intercept is pi 0, and the minimum is 3 pi over 2, -1. To find the points for this graph, you subtract pi from x and you multiply y by -3. So for the first point, you subtract pi from 0, which gives you -pi, and you multiply 0 by -3, which gives you 0. For the maximum, you subtract pi from pi over 2, which gives you -pi over 2, and you multiply 1 by -3, which gives you -3. For the second x-intercept, you subtract pi from pi, which gives you 0, and you multiply 0 by -3, which gives you 0. For your first minimum, you take 3 pi over 2 and subtract pi, and you get pi over 2, and you take the y, -1, and multiply it by -3, and you get positive 3. Then you continue with this pattern of the graph, and it will give you your graph for y equals -3 sine multiplied by x plus pi.
My equation is cosecant 4 pi x. This equation is compressed horizontally because of the 4 pi in the parentheses. This function does not have amplitude or frequency because cosecant is not a wave and has vertical asymptotes. The period of this equation is 1/2 because 2 pi over the absolute value of b, and the absolute value of b is 4 pi. This function does not have a phase shift because there's no c in the equation.
My function is y equals -1/2 cotangent, parentheses x minus 3 pi over 4, close parentheses. The graph reflects over the x-axis because of the function being a negative. It vertically compresses because a is 1/2 and 1/2 is less than 1, causing it to compress. The graph also moves right 3 pi over 4 because 3 pi over 4 is inside the parentheses, and it moves right because it is negative. My function does not have an amplitude or frequency because cotangent is not a wave and has vertical asymptotes. The period is pi over the absolute value of b, and the b of my function is 1, so pi over the absolute value of 1, which makes the period pi. The phase shift of the function is -c over the absolute value of b. The c in this function is -3 pi over 4, and the b is 1, so it's 3 pi over 4 divided by 1, making the phase shift 3 pi over 4, causing the graph to move right 3 pi over 4. To graph this function, you use the original cotangent points. You add 3 pi over 4 to the x and multiply the y by -1/3. Your asymptotes are at -5 pi over 4, -pi over 4, 3 pi over 4, and 7 pi over 4.